Welcome back to 3 Inquisitive Kids. In this video, we will be going over a series of problems that are all connected to each other on paint mixtures. Technically, these type of problems are all based off of ratios and how well you can use them on word problems. So here's our first problem. Shondra wants to mix some paint cans that are 1 part red to 2 parts green with some other cans that are 1 part red to 6 parts green. Her goal is to come up with a mixture that is 1 part red to 3 parts green. How many of each can will she need? Remember, they're emphasizing the need to make this mixture. So first we have red to green, and our ratios are 1 part red to 2 parts green and 1 part red to 6 parts green. And we want the result to be 1 part red to 3 parts green. We can first turn 1 to 2 to 1 to 3. And what I did here was I added 1 and 2 together to get the total number of portions, which is 3. And we're going to do the same to the second ratio as well, which turns it into 1 to 7. And our last result ratio would be 1 to 4. And then now we're going to take these 3 numbers, which is the total number of portions, and then make them into their least common multiple. So the least common multiple would be 84. The first ratio would be turned into 28 to 84. The second ratio would be turned into 12 to 84. And the last ratio will be turned into 21 to 84. So basically, we are trying to get to 21. Let's say that this line is 21. And if we keep adding portions of 28, we will always have an extra 7. And if we keep adding portions of 12, we will always have 9 less portions compared to what we're going for. And what we're going for is 21. Now we basically have a positive 7 and a negative 9. And this midline, we can actually turn it into 0. So it's either 7 above, 7 extra, or 9 less. And 0 is just right. So now we have to write out an equation. Let's assume that there are X cans of this first mixture and Y cans of this second mixture. 7X minus 9Y would have to equal 0, right? Because at some point, these cans combined will equal the just right portion. We can continue to simplify to get 7x is equal to 9y. And x over y equals 9 over 7. Now, as you can see, we've got our ratio. X to y is 9 to 7. So it means that there are 9 portions of the first mixture and 7 portions of the second mixture. And that is our answer. Now let's take a look at our second problem. Petra, hearing that her friend Shondra was going to paint her room, decided to do hers too. She chose to mix some paint cans that are 3 parts red to 5 parts green and some other cans that are 1 part red to 7 parts green. Her goal is to come up with a mixture that is 2 parts red to 7 parts green. How many of each can will she need to make this mixture? Again, we can apply the same method we did to the first problem. If you decide you got the hang of it, you can first pause the video and see if you can solve the problem. So let's first write out our ratios. Red to green. Mixture X, which is the first mixture, is 3 parts red to 5 parts green. And the other mixture, mixture Y, is 1 part red to 7 parts green. And her ultimate goal is to come up with a mixture that is 2 parts red to 7 parts green. And how many of each can will she need to make this mixture? We can first take one of these colors, red or green, and then compare it to the total number of portions. Last time we did red. This time let's pick green. So we can rewrite this first ratio to be, let's write it over here, 5 to 8. 5 is how much green portions there are, and 8 is the total number, 3 plus 5. And for our second ratio, mixture Y, it's 7 to 8. And our final goal would be 7 to 9. Now we have to change the total number of portions or units to be equal. And in order to do that, we have to turn it into their least common multiple. So their least common multiple would be 72. Now let's go ahead and do that. For x, we multiply both sides by 9. So we get 45 to 72. Y, we get 63 to 72. And for our result, we have to multiply by 8, 56 to 72. And now let's draw our little diagram. We want to get to 56. And if we apply an x, it will be 11 less than 56 because 56 minus 45 is 11. So it would be minus 11. And if we apply a y mixture, it will be 7. 63 minus 56 is 7. So we're trying to get to the just right amount here. When we approach the just right amount, in the end, the number of 7s and negative 11s added together would equal 0. So basically, we can write out an equation. Negative 11x plus 7y equals 0. 7y equals 11x. And then we get y over x equals 11 over 7. So in this case, we know that there are 11 portions of y and 7 portions of x. So now we have to go and write our actual answer down. We have 11 portions of the first mixture and 7 portions of the second mixture. And so that is our answer. And here's our third problem. Petra's brother, William, likes the colors, but not in those relationships. He cleverly decides that he wants to make some paint cans that are 62.5% red and 37.5% green, with some other cans that are 87.5% red and 12.5% green. He wants to end up with a mixture that is 7/9 red. What is his mixture, and why did he think this was clever? So we first have to find what William's mixture is. So we can still write out our ratios. R, red, to green. We have two mixtures, X and Y. For the first mixture, we have 62.5% to 37.5%. We can first write it just as 625 to 375. And this is okay because they are technically equivalent ratios. We can also do the same for mixture Y. And then now we can go simplify. Mixture X turns into 5 to 3, and mixture Y turns into 7 to 1. And William is trying to get a result of 7/9 red. Notice in this case, he said 7/9 red. So it means that 7 portions are red, and the other 2 out of the 9 portions are definitely going to be green. Now we have our ratios. We can go ahead and apply our method. So first, we can choose one color, red or green. This time, let's use red. For X, we have 5 to 8, 7 to 8, and 7 to 9. We're turning the second number in the ratio to be the total number of portions. For the first one, it was 5 plus 3 equals 8. Second one, it was 7.1 plus 1 equals 8, and so on. And then we're going to turn these numbers into their least common multiple. So we have 45 to 72, 63 to 72, and 56 to 72. we could go ahead and draw out our diagram. If it's mixture X, we have minus 11. If it's a mixture Y, we have plus 7. When we write out our equation, we get minus 11x plus 7y equals 0. So then 7y equals 11x. And when we get our ratio, we have 7 over 11 equals x over y. So then there must be 7 portions of x and 11 portions of y. So we could go ahead and write William's mixture is 7 portions of the first mixture and 11 portions of the second mixture. And we're not done yet. We still have to figure out why William thought he was the clever one. So let's first go back. For our previous problem, our answer was 11 portions of the first mixture and 7 portions of the second mixture. For this problem, it's the exact opposite. Basically, Petra's brother, William, thought that he was being clever because he was taking the same colors but swapping the portions around. And then he changed up the numbers to be very complicated, but luckily, he did not trick us. Here's our last problem. When Susie moved into her new home, she found 6 cans of 1 to 3 red to white mix and 6 more cans of 2 to 5 red to white mix. She's wondering what the mix will be if she combines all of these 12 cans. What will it be? Let's first write out our ratios. Red to white. Our first mixture is 1 to 3, and our second mixture is 2 to 5. And there's 6 cans of each. First, what we do, before we combine, we have to find the total number of portions that each ratio has. In the first case, we have 1 plus 3, which is 4 total. And in our second mixture, we have 2 plus 5, which is 7 total. As you can see, 4 and 7 are not equal. That means the size of each portion is not the same. If our unit is not the same, just like in many other problems, you can't compare them. You can't compare an apple to a pear. So now what we do in order to make these the same? Well, we're going to turn them into the same number. And we're going to do that by using our knowledge of the least common multiple. So the least common multiple of 4 and 7 would be 28, which means to the first ratio, we are going to multiply each number by 7. 7 to 21 to 28. In our second ratio, we're going to multiply by 4. 8 to 20 to 28. Now we have our ratio with a standard unit. This is red to white. So now we can ignore the 28, and we know that there are 6 cans of each mixture. So we can multiply 6 to each of these numbers. We have 42 to 126, 48 to 120. And then we're going to combine all these 12 cans to get 90 to 246 red to white. And as you can see, we can continue to simplify further down. When we divide both sides by 2, we get 45 to 123. And then we can divide both sides by 3 to get 15 to 41. This will be our ending ratio. So then the mixture would be 15 to 41, red to white mix. Thanks for watching this video, and I'll see you in the next one.